Namaskar and welcome back to our series of lectures on development and applications of special concretes, which was a course developed under the massive open online course initiative of the Government of India, that's MOOCs. And today we are closing the course with this very short lecture 32. We did the material in this course over 8 weeks, which was divided into 8 modules. To recapitulate, Modules 1 and 2 dealt with the review of normal concrete. Module 3 dealt with curing cold and hot weather concrete and the importance of specifications. Module 4, we went through a discussion on underwater concrete and roller compacted concrete. In 5, we dealt with self-compacting concrete. In 6, we learned about fiber reinforced concrete and had a treatment of rheology. In module 7, we talked about some mixers, the different kinds of mixing processes, shotcrete and high strength concrete. And in this last 8th module, we talked about polymer concrete, steps that can be taken to improve the cover concrete, a little bit about compaction and vibration of concrete, and a brief lecture on precast concrete. So as far as special concretes is concerned, we covered it from the dimension of using special materials or materials which are not normal, that is cement, water, sand, and coarse aggregate. We talked about fibers, we talked about polymers, and we talked about mineral admixtures, chemical admixtures, and so on. Then we talked about processes and methods that are used. Concretes like shotcrete come under that kind of a discussion. We talked about special environment, concrete being placed under special environments like underwater, hot weather, cold weather. Special properties, self-compacting concrete for that matter has a special property of self-compactability. High strength concrete has the property of strength higher than normal. So basically we said throughout that there is a normal range of variables and then there is a special part. And once any one or more of the different processes involved, that is mixing, transportation to placing to curing, any of these things becomes a little special, all the other processes need to be appropriately redesigned or rethought of. So that has been the central thought that has run through all these 8 modules, and that is why we spent module 1 and 2 reviewing our understanding of basic concrete or normal concrete, where we talked about the properties of fresh concrete, the properties of hardened concrete, basic curing methods, and so on and so forth. One thing which I could not touch upon, and I would have loved to do it perhaps, but there was not time, was we could not include a discussion on environmental impact of concrete construction. That would have included topics such as using construction and demolition debris, assessment of the life cycle cost, sustainable construction, green construction, rating systems for buildings, rating systems of construction, rating systems for concretes, and so on. That's something which got missed out in this discussion that we had over the last 8 weeks. But I would like to just share with you a small flowchart here, which is from the processing of C&D waste, construction and demolition waste or debris. So if we want to reprocess it and use the construction and demolition waste or reuse construction and demolition waste as partial replacement of virgin raw materials in our construction process, then this flowchart tells us basically the kind of steps that are involved or that will be involved. Once the raw material comes in, that is, once the construction and demolition waste is received at the C&D processing facility, there is an initial inspection followed by segregation. Now, this segregation is a very important exercise where some things which become a part of this C&D waste have to be simply rejected. They have to be taken out. That could include rags, plastics, metals, FRP sheets, and so on. Wood, for that matter, will be part of this. that has to be removed. Whether it's done manually or we have different ways of doing it, if it can be done automatically, things have to be rejected. They have to be removed. The second part of this segregation process is taking out big concrete blocks, which can then be crushed to 20 centimeter to 40 centimeter kind of blocks, and then using a dry process crushed further to 10 to 20 mm, 5 to 10 mm, 5 mm to 75 micrometers and so on. So this is basically the dry process applied to large chunks of concrete. Now, apart from these large chunks of concrete, we will have a mixed C&D waste which has to be processed further, and there will be whole bricks, which in Indian context is very important because we use a lot of clay bricks in our construction process, and those clay bricks are definitely a part of the C&D waste. So as far as these whole bricks are concerned, they need to be kept separately for internal use. That is, these bricks can be used as it is in some kind of construction. Now, coming to this mixed C&D waste, they pass through a filter, and if it is something larger than 200 mm, for example, it goes back into this side here, which is crushed. If it is less than 200 mm, then you go to an impact crusher, reduce it to about 60 mm, and then use a wet process again to create aggregates and sand kind of material out of the C&D waste that we have. So there are different ways of doing it, but this basically outlines the steps that are involved in recycling construction and demolition waste in an effort to use at least some of that material to conserve a part of the raw materials or the virgin raw materials that will otherwise be used as a construction material in our endeavor to keep making or using more and more concrete. Bringing recycled materials to the mainstream construction, that's something which we really need to think about. IS 456-2000, for example, which is the basic code for design and construction of concrete structures, it allows us to use aggregates and sand not drawn from natural sources to be used in aggregate, but that is with the permission of the engineer in charge. So what we really need is a sensitization of engineers in charges, the clients, and the professionals to permit or encourage or accept the use of material made from C&D waste, which is basically going to come under this category, that sand and aggregate not drawn from natural sources, to be used in construction of concrete. It's difficult to have recycled aggregate to satisfy the requirements of natural aggregates. Hence, the real need is to look for the possibility and implications of lowering the bar for aggregates to be used in concrete for at least certain grades of applications of concrete. So that requires a little bit of a mindset change. A thought process has to be initiated, awareness has to be created. I would have probably liked to spend a little more time discussing the different issues involved here and the state of the art as far as India is concerned and as far as Europe or other parts of the world are concerned. But that's now something which I'm leaving to you to sensitize yourself, try to do some literature survey on your own, and move forward. Having said that, let me try to reiterate what the approach that I have adopted as far as this course is concerned. I've tried to strike a balance between the science involved in the different processes and the practice and practical considerations. To me, concrete construction is a very practice-oriented field, but it has a very solid and important foundation in science. And therefore, practitioners need to understand the science, and the scientists need to understand the practice of cement, concrete, and cement concrete constructions. I've largely adopted an engineering-centered discussion and not a science-centered discussion, though I've tried to keep the principles of science also in the foreground, and used the codes of practice to emphasize the importance of accepted rules and standard operating procedures. I've tried to focus on special provisions that will be needed to be drawn up for quality control when we are using special concretes, whether it's in terms of materials, processes, properties, or environment. This has been our central theme. How will we do quality control when we are using fiber reinforced concrete or using shotcrete or underwater concrete or self-compacting concrete, roller compacted concrete? So the special provisions that will have to be brought in, and how the existing provisions or normal provisions or provisions for normal concretes, how they need to be adapted. That is something which I've tried to emphasize throughout the course. You will recall our discussion that we had in terms of preparing panels for shotcrete in order to get samples which can be used then for determination of compressive strength, or collecting the samples of underwater concrete in a tank of water. So these are the kind of special conditions that need to be incorporated in our testing mechanisms or testing systems, and one should not be afraid of creating new SOPs if the situation so demands. So with this, we come to an end of our discussion in this module and this course, and I would like to once again thank my teachers at Tokyo University and India and Japan, my friends in the corporate world and the academic world who have helped me understand and gain insight into this wonderful material. And I would like to thank the students at IIT Kanpur for all their questions, which has helped me understand the material better, explain it possibly better. And for this course, I would like to thank and express my gratitude to Dr. Prasanna Kumar Behra and Mr. Jinish Shaji, who helped me in so many ways all through the course. I take this opportunity to wish them well in their endeavors. And finally, I must also thank all of you for having gone through these lectures. I hope that you found them interesting and it has helped you gain some insight into this construction material. I've enjoyed being with you in this course, and I hope you have enjoyed the course too. Thank you once again, and I look forward to meeting you again in another course sometime, and I wish you all the best in your endeavors. Thank you.